Now 3.
Okay, so I'm not going to keep you guys for too long. I know I've heard from a lot of people. We're stressed out about lots of stuff going on. So a couple reminders. We have our unit 11 test tomorrow. It will be on Go Formative. And it's during class. Okay, and remember the unit 11 covers half of it is least square regression inference. So LSRL inference. And then the other half is which inference procedure. That's kind of what we've done since we came back.
What about LSRL test?
Yeah, so inference covers confidence interval and test. Big bubble, okay? So that both of those will be on the test tomorrow. So hopefully y'all finished the review on AP Classroom yesterday. Did it go pretty well? I haven't looked at any of the results. How did we do?
I get confused sometimes with quantitative versus categorical.
Okay, so the comment was, so you guys can hear, sometimes there's confusion about deciding if it's categorical or quantitative. So remember a proportion, like think about the proportion of red M&Ms in a bag or the proportion of people who are going to vote a certain way in an election. If it's a yes, no kind of answer, like if it's binary, that's technically a category. You can think of it yes or no, or red or not red, that kind of thing. If anytime it says average or mean, that's going to tell you, that's a good indication it's going to be quantitative. So even if it's talking about like yesterday, the problems that we went over yesterday or the day before with the ovens, right? Trying to figure out what we were talking about. It was talking about the average of percentages. So percentages, usually we're thinking, oh, that's categorical. But because it was talking about the average of all of those, it was a mean, a paired t-test because it was talking about mean difference. Okay, so I'm happy to answer any questions you guys have, but I did get some questions about the skinning. And so I want to kind of go over that and what's expected. And then do you have another different kind of question?
Yeah, about the difference between ChiSquared test performance.
Okay. So I'll answer that one first. So the question is, what's the difference? How do you know basically if it's a chi-squared test for homogeneity or a chi-squared test for independence, which independence and association, those are interchangeable words. So chi-square okay, so the process of conducting a chi-square test for either of these is exactly the same. This is the one where you do the matrix, you put your matrix with your actual values, you have a two-way table, all that. So when you're trying to identify which test to use, it's all about how you collected the data. That's the only thing you really have to look at. Once you've narrowed it down to two-way table, categorical, then you need to look at how the data was collected. So if it's independence and association, this represents one sample, and you're making inference about one population. Literally, oh my goodness.
There we go.
Okay, water bottle issues, right? And you have a, think you could have a, two-way table here. right, with two variables. Okay, two variables that take on different values. So you can have multiple rows, multiple columns, but it's going to be, you're just going to have columns and rows. The key is that there's one sample that represents one population. Homogeneity, you're comparing a distribution across or two samples. Which is two populations. And this also includes anytime you have an experiment. Okay, because when you have an experiment, you're comparing a treatment and a control group or two treatments.
Take one sample and then they sort the results into two different categories. That's when they take two samples, one from each population.
That's exactly right. That's exactly right. And so if it's two populations, if it's samples and it's two populations, what you'll see, you might be comparing the distribution of you have two distinct populations, literally, like United States and Canada, and maybe we're comparing the distribution of race in each category, in each place. So race and ethnicity. Right, so you have several categories, right, that are within each of the countries. And then we could compare the numbers of people in each country that fall into that specific category. Does that make sense? Okay. And then, but the tricky one, I think, if you just remember that for anytime you see an experiment, if it's chi-squared, it's going to be homogeneity. That's the one that people kind of miss because it looks like it's one population. But when you've randomly assigned that one group to two different treatment groups, all of a sudden you've kind of broken them into two distinct treatments, which are considered two distinct populations, if that makes sense. Okay. Any other like general questions like that? You'll come up with some. Okay, let me just talk about the skinning, because I've had a couple people ask if I could give a little bit more direction on what's expected for the skinning. So I typed up a few things. Okay, so on the assignment sheet, well, first of all, in your skinny project assignment, it gives you all the details about what's expected in each unit. But for the unit 11 skinny topics, what I did, I just went in and you already have all the main headers of each of these. And I kind of beefed it up to give you lots of info here about where you can find stuff. So in class, after I think a lot of you guys had logged off yesterday, but we had some questions about, for the first section, 11.1, the notation for the statistics and the parameters. So let me just back up a second, like, or 30,000 feet view of all this. At this point, do we understand what we're doing with inference? Like in general? Okay, so inference covers both confidence intervals and hypothesis tests, right? When we want to estimate a population parameter, we're going to do a confidence interval. When we want to evaluate a claim or test a claim or provide convincing evidence, that kind of wording, that's when we're going to do a hypothesis test. So the big picture about all of these different procedures is we're collecting data from a sample or from an experiment, like small little group, and we're going to use our data that we get from whatever that sample is to make decisions, to make inferences about the whole population. Okay, so we did that with proportions. We did that with means. We did that with categorical data with chi-square. And now we're doing that with the relationship between two quantitative variables, X and Y variables, that we would show in a scatter plot. And so this unit is all about inference for the slope of the regression line, because the regression line is what shows the linear relationship between your X variable and your Y variable, if there is one, right? So it seems a little bit weird in this unit, but when we're talking about the statistic and the parameter in this case is that there is some least square regression line that defines the whole population you're trying to represent. So we, just like we always do, we always use Greek letters for the population parameter, and we use Latin letters, or whatever we, American letters, whatever we use in our regular English alphabet, I think technically Latin letters, we use those letters for statistics. So the population parameter, the least square regression line, would be the mean of Y is equal to alpha plus beta X. So the alpha is your y-intercept. That's your true y-intercept for your population. And then the B, the capital Greek B, beta, is the true slope of the population regression line. So those are your population parameters. But we're trying to usually estimate those or test a claim about those given the data we've collected from our sample. So most of the time we'll go out, we'll collect a little sample, we'll put our data in list 1, list 2, we do stat, calc, number 8 in our calculator, and poof, we get this regression, linear regression equation. Though that's written with, my hat didn't show up here. It should have a hat over the y here, right? Y hat is equal to a plus bx. But so a would be the sample y-intercept, so that's the statistic, and little b is the sample slope, that's the statistic, right? So when you're checking your conditions on the second part, you need to specify what the conditions are. So we went over this yesterday, linear, right? L-I-N-E-R, sorry, no A, but L-I-N-E-R, and what those are. So what you're looking for and how you would check those. On 11.3, computer output, there's notes. We've posted notes in on your OneNote notebook that has a bunch of examples about computer output. So you can just show an example of computer output, what all of those, the key values that are in the computer output, what those represent, how you would use those to write the regression equation, test the claim, find the standard error of the slope, get your test statistic, get your p-value. And remember, with computer output, when it gives you a p-value, unless it specifically says otherwise, that p-value represents a two-sided test. So you need to know, oh, well, if it's a one-sided test, you have to kind of think about that. Usually you just would divide the p-value by 2, assuming that the test is going in the right direction and all that. They're not trying to make you think beyond that. But say you have to divide by 2 to adjust that for a one-sided test. Okay. And then on 12.4 or 11.4 and 11.5, you should show your complete FRQ example for both a confidence interval and a hypothesis test. And we've put several answer keys out there on OneNote on the worksheets. There's tons of examples in the book. You just don't want to use the examples, worked out examples that are in the body of the textbook. Okay, any other example is fine. You just don't want to use that, and it needs to be in your own words. Okay, and then, oh, and for 11.4 and 11.5, I just want to specify, don't say, assume conditions for inference are met. I mean, that's great if you get one of those problems on a test, but in your skinny, you're supposed to use it as a reference, right? So you want to show how you're checking your conditions. So don't do that on the skinny. make sure you show how you're checking all those conditions. And then 11.6 is just the calculator keystroke. So how do you get to the confidence interval and the test? And then 11.7, all you have to do for 11.7 is put your completed graphic organizer that we did the other day about which inference procedure. If you want to put other helpful hints in there, that's fine. But we just want you to have that. Okay? Yes. Question. What? I can post it, sure. Well, I can email it to you. The assignment's out there, but I can put this, I'll put this in the content library section, so it won't like redistribute to you all, but you can check it out there. Okay, and then for today, it's just, there's a practice test and let's see. So there's a practice test that's on OneNote and, or will be on OneNote in a moment. I have to copy it over here. So you can do the Unit 11 practice test. The answers will be there. And then I've also, I've actually put a couple of old quizzes that just cover the regression, the linear regression. And I'll put that out there as well with the answers, just if you want something else to look at, to just little extra practice or more examples for your spinning. So any questions about any of the questions on AP Classroom, any of the textbook problems, any? Is what? Yeah, I'll put that on the OneNote. So your skinny's due tomorrow at 8 a.m., right? So. Okay, so hopefully that helps. The practice test is not for a grade, it's just for practice. Okay. So, all right, so people who are on Zoom, you guys are free to go to work on your skinny, whatever you need to do, work on the practice test. If anybody has any questions, hang out and I will be happy to answer them. Right?